We'll start in 1 minute. Today in section 4.3, we have more applications with systems of linear equations. So we'll look at the first one. Solve the word problems. Assign variables to quantities that need to be found. Find a system of equations, and then solve the system. In this one, 2 kinds of coffee are mixed to get 12 pounds at $6.25 per pound. One of the kinds of coffee costs $4.40 per pound, and the other is $8.84 per pound. Find the number of pounds of each in the mix. So we want to find the number of pounds of the $6.25 per pound coffee. Whoops, sorry, that's what we want to end up with. One of the kinds in the mixture is $4.40 per pound. The other one is $8.84 per pound. When we mix them together, the cost per pound will be somewhere in between $4.40 and $8.84. Specifically, the mixture will be $6.25 per pound. So we assign variables. Let's let X be the number of pounds of the $4.40 per pound. And let's let Y be the number of pounds of the $8.84 per pound. Okay, when we mix them together, X pounds plus Y pounds has to add up to 12 pounds. So this equation, first equation is X pounds plus Y pounds is 12 pounds. And then the next equation takes into account the monetary value of each of those quantities of pounds. If X pounds is worth $4.40 per pound, then the value of that is 4.40 times X. That will be measured in dollars. If Y pounds is worth $8.84 per pound, then the value that has is 8.84 times Y. And then the mixture of 12 pounds is worth $6.25 per pound. So if we multiply 6.25 times 12, that will give us the value of the mixture. Okay, so this is our system of 2 linear equations. Observe, as is always the case, in any particular equation, all of the terms represent the same kind of quantity. So in the top equation, each of the terms represents a certain number of pounds. X pounds plus Y pounds equals 12 pounds. In the other equation, every term represents a dollar value of a certain amount of coffee. So $4.40 per pound times X pounds, the pounds units cancel. And so the units are dollars, even though we're not writing dollars. But each of the terms in the bottom equation represents a certain value measured in dollars. So that's an important thing to remember. In any given equation, each of the terms has to represent the same kind of quantity. Okay, so we can solve using either substitution or addition. So I'll use substitution. I'll solve the top equation for x. That's just one of the choices. Solve for x. So x is equal to 12 minus y. And then in the other equation, replace x with 12 minus y. And then solve this equation for y. Okay, so 4.40 times 12. I'll write that as 4.40 times 12, and then minus 4.40 times y plus 8.84 times y. And that's equal to 6.25 times 12. So it looks like I might run out of space. I was just getting some extra paper so I can continue this. So on the left-hand side, we can combine like terms, the minus 4.40y plus 8.84y. That's going to simplify to positive 4.44y. And in the same step, we'll subtract 4.40 times 12 from both sides. So on the right-hand side, we have 6.25 times 12 minus 4.40 times 12. And since I'm operating without a calculator, I'll just do some algebraic maneuvers. So on the right-hand side of that equation, notice that each of the terms has a common factor of 12. So if I factor 12 out, then I have 12 times 6.25 minus 4.40. And then 6.25 minus 4.40, that is 1.85, I believe. Okay, then the last step, divide both sides by 4.44. So 12 times 1.85 divided by 4.44. Okay, I'll leave the rest of that for you to do. You're allowed to use a TI-30 calculator. And then once you know what the value of y is, you can use the fact that x equals 12 minus y to find the value of x. Okay, let's move on to the next problem. And the next one, $1,800 is invested in two accounts. One earns interest at 5%, and the other earns interest at 8%. Combined, the interest earned is 7%. Find the two investment amounts. Okay, so we have two accounts, so there are two investment amounts. And altogether, there is $1,800 invested. One of those amounts earns interest at 5%, and the other earns interest at 8%, and combined, the interest earned is 7%. Okay, so we have two quantities that we're supposed to find. Find the two investment amounts. So let's let x be the number of dollars. I'll abbreviate a little bit. Number of dollars at the 5% interest rate. And let's let y be the number of dollars invested at 8%. Number of dollars at 8%. And altogether, $1,800 is invested. So that means one of our equations is x dollars plus y dollars equals $1,800. So in this equation, each of the terms represents a certain amount of money that is invested. And then in the second equation, each of the terms represents the amount of interest that is earned. So if x dollars earns interest at 5%, then the amount of money earned in interest is 0.05 times x. And then if y dollars earns interest at 8%, the amount of interest earned is 0.08 times y. And altogether, the $1,800 earns interest at 7%. So here we multiply 0.07 times 1,800. Okay, so here is our system of two equations. So let's use the addition method this time. So I'm going to multiply both sides of the top equation by negative 0.05. Okay, so when I multiply every term on both sides of the top equation by negative 0.05, I'll get negative 0.05 times x, and then minus 0.05 times y equals negative 0.05 times 1,800. And the other equation I'll leave the same, and I'll rewrite it down here, 0.05 times x plus 0.08 times y equals 0.07 times 1800. Okay, so when we add these two equations together, the variable x is eliminated, and then negative 0.05y plus 0.08y, those are like terms, those combine to give us positive 0.03y. And on the right-hand side, we're adding these terms. Notice they have a common factor of 1800. So when I add them together, I'm going to factor the 1800 out, and we'll have 0.07 minus 0.05. So I'll go ahead and write that 0.07 minus 0.05. Okay, so we can probably figure this one out to the end. 0.07 minus 0.05 is 0.02. And 1800 times 0.02 is just 36. And so the value of y is 36 divided by 0.03. And this is the same as 36 divided by 0.03 is the same as 3600. Did I say that right? 36 divided by 0.03 is the same as 3600 divided by 3, which is 1200. Okay, so since x plus y is 1800, that means that x is 600. Okay, so our one sentence summary, we can say $600 is or was invested at at 5%, and the other amount, $1,200, was invested at 8%. Well, the underlying assumption is that the interest rates are annual interest rates. It would perhaps make more sense if we added that bit of information. Okay, let's look at the next page. Okay, this one is another interest or investment problem. Okay, this one says $4,800 is invested in 2 accounts. The 2 annual interest rates are 6% and 10%. The interest after 1 year is $4,000. Find the 2 investment amounts. Okay, so a total of $48,000 is invested in 2 accounts. And we're supposed to find those 2 investment amounts. The 2 annual interest rates are 6% and 10%. So we can assign X to be the number of dollars invested at 6%. And this time we're explicitly told that it's an annual interest rate. So at 6% per year is what that means. And let Y be the number of dollars invested at 10% per year. Okay, the total amount of money invested is $48,000. So one of the equations is X dollars plus Y dollars equals 48,000. So that's one of our equations. In the next equation, each term will represent an amount of annual interest. Okay, so if X dollars earns interest at 6% per year, then after 1 year, the amount of interest will be 0.06 times X. We add that to the amount of interest that Y dollars earns if it earns interest at 10% per year. So that's represented by 0.10 times Y. And we're told what the total amount of interest is in both accounts. So this has to add up to 4,000. If you are interested in getting rid of the decimal numbers, you can do that. If we multiply every term on both sides by 100, 100 times 0.06x is 6x, and 100 times 0.10y is 10y. And then on the right-hand side, multiply 4,000 by 100. We get 400,000. Okay, if you want to use the addition method, we can multiply the top equation. One option is multiply every term on both sides of the top equation by -6. So multiply by -6. And so -6 times x is -6x. -6 times y is, we write that as -6y. And then on the right-hand side, -6 times 48,000. And when we add these equations together, the variable x is eliminated. 10y plus -6y is 4y. And over here, we can write this as 400,000 minus 6 times 48,000. Hey, then if we divide every term on both sides by 4, we can write this as y equals 400,000 divided by 4, and then minus 6 times 48,000 divided by 4. And 400,000 divided by 4 is 100,000. And here, 4 goes into 48,000, 12,000 times. So this is the same as 6 times 12,000. And 100,000 minus 6 times 12,000 is 100,000 minus 72,000. And 100,000 minus 72,000 is 28,000. Okay, so that's the value of Y. $28,000 was invested at 10%. The total amount invested was 48,000. So that means X is 20,000. Okay, so X equals $28,000 was invested at 6% per year. And then the other one, Y equals $28,000 was invested at 10% per year. Okay, number 4 is another investment problem. Yeah, this one, $2,000 is invested in one account, and $5,000 is invested in a second account. The total interest earned in both accounts is $480. The interest rate for the $5,000 investment is twice the interest rate for the $2,000 investment. Find the two interest rates. Okay, so the interest rates, they'll have a percent. They can be expressed as a percent or as a decimal equivalent to the percent. Okay, so if we let X be the decimal form of the interest rate, for the $2,000 investment, and if we let Y be the decimal form of the interest rate for the $5,000 investment, so these are supposed to be interest rates. Okay, so we can write down two equations, one at a time. In the second sentence, we're told that the total interest earned in both accounts is $480. Okay, so for the $2,000 investment, if we multiply $2,000 invested times the interest rate X, this represents the amount of interest that $2,000 earns if its interest rate is X. We add that to the interest that $5,000 earns if the interest rate is Y. And then the total interest in both accounts adds up to $480. So each term in this equation represents an amount of interest. So I'll just say each term is an amount of interest. Okay, then in the third sentence, we're given information about the interest rates. It says the interest rate for the $5,000 investment is twice the interest rate for the $2,000 investment. So that's like saying, okay, the interest rate for the $5,000 investment, we're using Y to represent that. So we could say Y is twice the interest rate for the $2,000 investment. So if X is the interest rate for the $2,000 investment, Y is twice X. So how do we translate that? Y equals 2X is all we have to do, right? Okay, so we have two equations. And it looks like it's pretty easy to use substitution in this one, since Y is just equal to 2X. We substitute into this equation, and we'll get 2,000 times X plus 5,000 times 2X equals 480. So 2,000X and 5,000 times 2X is 10,000X equals 480. And so 12,000X equals 480. And then X is 480 divided by 12,000. Well, we can do some things. We can whittle this down a little bit. If we think of 480 as 48 times 10 and 12,000 as 1,200 times 10, 10 divided by 10 cancels. So we can write this in a little bit lower terms just by observing that, 48 over 1,200. Then notice that 12 goes into 48 4 times. So I'm canceling common factors. Think of 48 as 12 times 4. And think of 1,200 as 12 times 100. And 12 divided by 12 is 1. And then 4 divided by 100 is equal to 0.04. So this is the number we want. X is equal to 0.04. That means that the interest rate for the $2,000 investment is 4% per year. And since y is equal to 2 times x, then y is equal to 2 times 0.04, or 0.08. Okay, so 4% and 8% are the two interest rates that we are looking for. Okay, let's move on to the next problem. Okay, this is a mixture problem. 200 liters of an 80% acid solution is produced by mixing a 50% acid solution with a 90% acid solution. Find the number of liters of each. Okay, so we want to find the number of liters of the 50% acid solution, and we want to find the number of liters of the 90% acid solution. Find those two amounts so that when we mix them together, we get a total of 200 liters. That's 80% acid. Okay, so if we have two quantities to find, so if I pick X to be the number of liters of the 50% acid solution, and then pick Y to be the number of liters of the 90% acid solution. Now we can write down two equations. The first equation I'll write down. Each of the terms will just be a number of liters. So we're going to take X liters from one container and Y liters from a second container and put them together in one container to get 200 liters. Okay, so in this equation, we're not taking into account how much acid or the percentage of acid in each. Just think of this as taking X liters from one container, take Y liters from a second container, combine them in a third container, and we get a total of 200 liters. Okay, in the next equation, we'll take into account the percentages of acid. Okay, so if X liters is 50% acid, then how do we represent the amount of pure acid that it contains? Well, we multiply the decimal form of the percent times the number of liters. If X liters is 50% acid, then we multiply 0.50 times X. This represents the amount of acid that's in the X liters of the solution. Then we add that to the amount of acid that's in the 90% solution. So if Y liters is 90% acid, the amount of acid is 0.90 times Y. Okay, and the mixture, which is 200 liters, is 80% acid. Okay, so what should I write on the right-hand side?
0.8 times 200.
Yeah, 0.80 or 0.8 is okay, but I'll go ahead and write 0.80 times 200. Just a note, when you have a decimal, zeros added to the end can be used, but you can omit them also. So this equation is equivalent to writing 0.5x plus 0.9y equals 0.8 times 200. These two equations are equivalent. Okay, so we can use the addition method or substitution. So why don't we use substitution? Suppose I solve the top equation for y. So y equals 200 minus x. And then in this equation, I'll replace y with 200 minus x. So we get 0.5x plus 0.9 times the quantity 200 minus x. And if you want, 0.8 times 200 is just 160. And then it's a little bit of arithmetic. So 0.5x, 0.9 times 200 is 180, and then minus 0.9x equals 160. Combining like terms, 0.5x minus 0.9x is negative 0.4x. And we'll go ahead and subtract 180 from both sides. 160 minus 180 is negative 20. And so x is equal to negative 20 divided by negative 0.4. A negative number divided by a negative number is positive. And then 20 over 0.4 is equivalent to 200 over 4. And so x is 50. And then y is 200 minus 50, or 150. Okay, so 50 liters of 50% acid solution and 150 liters of the 90% acid solution are needed. Hey, the next one. So this next one might seem easy compared to some of the other ones. 35 quarters and dimes have a value of $6.50. Find the number of each coin type. So we have quarters and dimes. So let Q be the number of quarters. And let D be the number of dimes. So this one, let's just set up the system of equations and then go to the next problem and set up that equation, that system. Okay, so I have Q quarters and D dimes. So what's one of the equations in the system?
Q plus D equals 650.
Q and D don't represent monetary value. They just represent the number of quarters and dimes.
35 instead of 650.
Yeah, we have 35 quarters and dimes. So Q quarters plus D dimes is 35. So none of the terms in this equation represent a monetary value. In the next equation, every term does represent a monetary value. So what's the next equation or the second equation? Well, if I have 5 quarters, then what's the value of 5 quarters? $1.25. One way to think of that is multiplying 5 times 0.25. The number of quarters times 0.25 gives you the monetary value. Okay, so that's what we're doing here. Each of the quarters is worth $0.25. So the monetary value is 0.25 times Q. And then if I have D dimes and each dime is worth $0.10, then the monetary value of D dollars is 0.10 times D. And altogether, the 35 quarters and dimes have a value of $6.50. Okay, so I think that you can probably solve this system. Let's take a look at the next problem, number 7. Now this is pretty similar to the one that we just did. $48 $5 and $10 bills are valued at $345. Find the number of each denomination. Okay, so if X is the number of $5 bills, and if Y is the number of $10 bills, then we can write down a system. Altogether, we have 48 $5 and $10 bills, and the value of all of that is $345. So what's one equation?
X plus Y equals 48.
Yeah, X plus Y is 48. So this is just the number of bills. We're not taking into account the value of them. And then in the second equation, every term will represent a value. So if I have X $5 bills, what's it worth?
5X.
Yeah, 5X dollars. And if I have Y $10 bills, it's worth 10 times Y. And then the total value is $345. Okay, so here is our system. So we'll end on this one, but just a note, notice that we can get a simpler equation if we divide every term on both sides of this by 5. So the numbers will be pared down a little bit and consequently easier to work with, perhaps. If you divide every term on both sides by 5, we get 5x divided by 5 is x, 10y divided by 5 is 2y, and 345 divided by 5 is 69. Okay, we're out of time now, so go ahead and sign in for attendance.
Have a good one.